Hello, dear students. Today we have proposition 7 of book 4. About a given circle to circumscribe a square. Proposition 7, book 4. About a given circle to circumscribe a square. Let this be our given circle. Thus it is required about this circle to circumscribe a square. Let's take the center. Let's drop a line to the circumference. Extend it. Have this be your center. And then from the point on that line, drop a perpendicular up until the circumference. We know we can do that given a point on a line to make it perpendicular. So all these are perpendicular, okay? We'll just do one of them. Great. Now from our point of contact, intersection, let's make some tangents. We do that, we've proven that by making these right angles. Okay, continuing. Likewise here, tangent, touching the circle, tangent, touching the circle, not right angles. Okay, tangent, touching the circle. Sorry about that. Now we need to, the pattern's going to be, we're going to show that this is parallel to this, it's parallelogram. We're going to show that they're equal. And then we're going to show that the angles are right, little by little, okay? So, let's show that this is parallel to this, okay? So we got, we'll just start here. This has been made a right angle, and this has been made a right angle. Remember we dropped that at right angles? So, a straight line falling upon two straight lines, two straight lines making the interior angles equal to two right angles. Therefore, those two straight lines upon which that line falls are necessarily parallel. So this is parallel to this. Likewise, this is parallel to this because right angles, same reason. Two things parallel to the same thing are parallel to each other. So this is parallel to this. Likewise here, because this is a right angle and this is a right angle, this is parallel to this. And for the same reason, this is parallel to this. Two things parallel to the same thing are parallel to each other. This parallel to this. Great. So, and opposite sides of parallelograms are equal. So this is equal to this, and this is equal to this. Opposite sides of parallelograms. So we have, this is a parallelogram because these are joined here. And how do you know that they joined? Because if they didn't join, if these two lines, if this line didn't meet with this line, say, you gotta figure out how that, anyway, Euclid doesn't talk about that too much, and I'm not gonna worry about it right now, but by showing that angles are going to be less than two right angles, these lines are eventually going to meet. Say, I think you just connect these two lines. Like here, if this is a right angle and this is a right angle, this little thing and this little thing are less than right angles, so therefore added together, less than two right angles. Therefore, a straight line falling upon two straight lines, creating interior angles less than two right angles, they're eventually going to meet. So we know that this is going to meet this is going to meet this, etc. Okay? So you have parallel lines being connected, and they're parallel as well. So opposite, now this is a parallelogram, and now we know opposite sides of a parallelogram are equal. This is equal to this, and this is equal to this. Now we need to show that this is equal to this, because opposite sides of a parallelogram are equal. It could be like this. Parallelogram, say, like this. Opposite sides are equal, but that doesn't mean that the four sides are equal. We have to show that the four sides are equal. Well, this is equal to this because this is, oh, by the way, everything here is a parallelogram. This now is a parallelogram, this 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 is a parallelogram. It's all parallelograms, okay? For the same reason that this was shown to be a parallelogram. Great, opposite sides are equal because this is a parallelogram, this is equal to this. Opposite sides of a parallelogram are equal. This is a parallelogram, this is equal to this. Two things equal to the same thing or equal to each other. This and this are equal to this, but this is equal to this because they're diameters of the same circle. Okay, so this being equal to this, and also being equal to this is also equal to this and this. But these two things, because these are parallelograms, are equal to this. So because these two things are equal to this, and these two things are equal to this, these two things and these two things are all equal to each other, okay? Two things equal to the same thing or equal to each other. So We've shown that this is a parallelogram. We've shown that it's equilateral. Now, if we show that these angles are right, it'll necessarily be a square. And it will be touching it because these are tangents to the circle. The sides are tangents. Let's show that it's a square. That is to say, all its four sides are each equal to a right angle. Parallelogram, opposite sides of parallelogram are equal. This was made a right angle. Therefore, this being equal to this is a right angle as well. Likewise, this being equal to this, and this being a right angle, this is a right angle. Likewise, this is a right angle. Likewise, this is a right angle. Good. Here, this little red figure, which, by the way, doesn't in any way cut the circle, but its four sides are coming in contact with the circle, touching the circle. So this four-sided figure is circumscribing this circle. It's a square because this four-sided figure has four sides equal and each of its angles equal to a right angle. Therefore, we have shown that it's possible to circumscribe a square about a circle. Quod erat faciendo. Thank you. Bye.